Okay, so welcome to Guided Practice on scientific notation with negative powers of 10. Let's get started. We're going to write this first number in scientific notation, and I'm going to put that here, 0.000487. Now the first part of scientific notation should be pretty easy. You create a number between 1 and 10 using a decimal, and then it's times 10. All right? Now, uh, let's think about what we're doing here. We are placing the decimal here. I'm going to zoom in a bit here. We're placing the decimal right here, right? We just did that here, but it really belongs over here. Now that means I have to move the decimal 1, 2, 3, 4 times. Now, if I did this right here, this would be wrong, wouldn't it? Because if I have 4.87 times 10 to the fourth, what that's doing is it's 4.87 and it's moving it 4 times to the right. 1, 2, 3, 4. But that's not what I want. I don't want to move this to the right. I want to move it to the left. So that means I'm going to move this to the left. And so I have this here, that negative, that is going to move it. Because if this exponent was a positive, then I'd be moving this 4 times to the right. But if it's negative, I get to move it 1, 2, 3, 4 times to the left. Done. That is done. Now there's more stuff going on in the background, but in order to be able to do this, there you go. That's the main thing. So here, if I have this, so I want to place the decimal here, so it's 2.8 and then times 10, and then but where does it belong? 1, 2, 3, 4, 5. I have to move that decimal 5 times. So if I move it to the right, it's wrong. I have to move it to the left, so that's a negative. And one thing to know here is these are small numbers, and so small numbers have negative exponents. Large numbers have big positive exponents. That's just a general rule. So this is that. And in all of these, we're going to have negative exponents. This one, I place the decimal right here, and so it's going to be 5.9, and it's going to be times 10 to the negative 1, 2, 3, 4, 5. I'm going to count that. Times 10 to the fifth, or actually negative fifth, because I'm moving the decimal to the left. This is 4.17 times 10 to the 1, 2 times 10 to the negative second power. Because if it was to the positive second power, it'd be moving the decimal this way. And I don't want to move it to the right, I want to move it to the left. Picoplankton can be as small as that centimeter. Okay, so it's 2, right? So it's 2. I place a decimal there. I need to move it 1, 2, 3, 4, 5 to the left, so it's times 10 to the negative fifth. And number 6, the average mass of a grain of sand on a beach is about, well, let's see, 1.5. And I place it there, but it needs to go 1, 2, 3, 4, 5 times 10 to the negative fifth, and that's what we should get. See, we're just moving the decimal, and that negative tells us the direction that we're moving. Okay, so we're going to write this in standard notation, and I'm going to get a little bit, okay, good. So times, let's see, 2 times 2 times 10 to the negative fifth. That means on the decimals right there, and I have to move it 1, 2, 3, 4, 5 times, and I fill it in with zeros. So again, that 5 is not going to tell me how many zeros I have. It's how many times I move the decimal, and I have to move it to the left. So it looks like this with, what, 4 zeros. And for this one, I'm just going to go right into the problem here. So that -6 tells me this is going to move 1, 2, 3, 4, 5, 6 times. And I have 5 zeros there. So there you go. And I think I have 1, 2, 3, 4, 5 zeros. And then I have that same number right there. And this one, this is going to be pretty easy because it's going to be 4 to the left. So it's going to be 1, 2, 3, 4. There's going to be 3 zeros here. And maybe I'll just draw it out. So 1, 2, 3, 4, right? And then there's 3 zeros right there. That's where we get this number right there. And 2.97, I just have to move it 2 times to the left. So 1, 2, 1, 0 right there. And I have that. So that's, yeah, 0, 2, 9, 7, 0, 2, 9, 7. And this other one, we have times 10 to the -5th right there. So move it 1, 2, 3, 4, 5 to the left, and you have 4 zeros. So that's where we get that. And this one, there's what we're going to move it 5 to the left. So the decimal, tricky, the decimal's right here. So you move it 1, 2, 3, 4, 5 to the left, and there's 4 zeros. You might have noticed that there's one fewer zero than the exponent has by now, right? Because there's 4 zeros, but the exponent's 5. There's 1 0, but the exponent's 2 or -2. And let's see, the average length of a dust mite is approximately that much. What's the number in scientific notation? Well, I have to, let's see, 0.0001. I have to make a number from 1 to 10, so it's 1. All right, I'm going to place the decimal right there, times 10, and then I have to move it 1, 2, 3, 4, times 10 to the -4th because I'm moving it to the left, and there. The mass of a proton is about 1.7 times 10 to the -24th grams. Write the number in standard notation. Oh boy, there's going to be 23 zeros, aren't there? Because I have to move it 24 times to the left, and there's one spot taken up right there. So it's going to be huge. There's going to be 23 zeros. 23 zeros. Oops. There are 23 zeros and then a 1 7. And the last one, describe how to write something in scientific notation, or that number. Well, this is what you do. Oh boy, there's a lot going on here. So move the decimal 5 places to the right to find that, it's greater than or equal to 1 and less than 10, so a number between 1 and 10. Then multiply that by negative to the -5th, right? Tells you how many spaces you moved. So there you go. That's what you got to know about scientific notation and negative powers of 10, lesson 15.3, the guided practice. Thanks for watching.